any of that stuff. All right, guys. Anybody else have any other questions on homework? I've got a very interesting message that's not finished up there. So we'll finish that in a minute. Nothing else on homework. Somehow I don't believe that. Some of these things are a little bit nifty. Okay. All right. Have you guys had a chance to look at your quiz? Is there any questions from the quiz?
How do you do the bonus problem?
Oh, yeah. So several people got that one right. I just got a question from homework, but hold on. There was a range of things I would accept because it is a very strange question to answer. So the way you look at it, if you graph that bad boy, and by the way, when you make corrections, you get one shot at bonus. So you've already had your shot at the bonus. So I don't mind just doing the bonus. Let's see if I can remember. I think it looked something like this, right? Wasn't it a butt graph? I can't remember now.
Yes, that's what it
People that did it?
Yeah.
So it currently has 4 real zeros, right? We sort of did a problem. I feel like we did a problem like this before, a different one, but this is a very strange pose I'm taking with the butt graph. But if I could push this up far enough, it's not going to hit the x-axis anymore, right? I like it. So anyway, so if you knew what this was, if you knew what value that was, that's how much you want to add, and then just like a smidge more, which is not a mathematical term, but one of you guys, I like the way that you capture the idea of a smidge more. And then some other people kind of explained, and then some people put like 0.1. Anyway, does that make sense right there? I mean, it's, if you know how deep.
I just looked at the bonus problem and was like, I don't even understand what he's asking, so I just skipped it.
Oh, I got you. Okay. No
I didn't
worries.
attempt, so I was just curious.
Yeah, so that was the idea.
Okay.
Yeah, there's something else I want to say about that, and I can't remember. That's all right. Oh. If I have an odd degree overall polynomial, it's going to either look like this or like this, of course, right? So I don't care how much I raise or lower this thing, it's going to always have at least one real root.
Mm-hmm.
Cool. All right, I just want to say that. If I have an even degree overall polynomial, then it's possible it has nothing but complex roots.
Okay.
That's a possibility, yeah.
You said someone had an interesting way of showing their solution to that problem. What did you mean by that?
Yeah, I can't remember exactly. It was, what did they say? I like the way they said it, because this turns out to be -36. So the question is very strange to answer because you can't just add 36, because then it would look like, you could do it just there. It would hit the thing twice, and you still have 2 real roots. So it's got to be a little bit more than 36. So somebody did this. That's what they did, and I really appreciate that. That's not technically correct. That is nothing that you would ever write in a mathematical journal. But this idea of forever zeros and then a 1 at the end, that's beautiful. That's exactly what a smidge is in mathematics. Not technically, but I still enjoy the creativity. So I can't remember who did that, but somebody did. And then there were other ways to say, just a little more than, so some people just said 36.1, which gets the idea, but why did you have to add 0.1? You could have added 0.01 or 0.001, but you know, I wasn't going to be that picky. I have a question from homework. This is in section 5.6. Let me see. Number 9. Oh, okay. So somebody was asking, I think it was Jason was asking about this one. The main focus for a domain of a rational function. Where's your main focus? Not your only focus, but your main focus. Where would a domain be restricted? What part of it would restrict the domain?
The
Anybody?
denominator.
The denominator. So the only, so I didn't make this point fully. Even if something canceled out on the top, that value is still not in the domain. Right? Because there would be a what there if it canceled out with the top. So if the bottom and the top are both factorable, and there's a factor that cancels, right? Would that value still be in the domain or not? So we just had this. Go ahead, sorry.
They're in circle.
Yeah, open circle, meaning that's not a part of the domain or the range for that matter, that one piece. All right. Is that enough for that, or did you have trouble factoring the bottom, or what happened? Is it okay besides that? Person that asked the question. Oh, I see. Okay. All right. So what is it about the bottom that tells me it is possibly factorable? I think we talked about this a couple times.
The x squared and the x to the fourth, you can do some magic.
Yes. My magic will
What's
work.
the word I'm looking for?
So the middle degree is half the first.
That.
Therefore, I can factor this bad boy. Because when I go to factor this, the first thing I do is try to cut this dude in half, right? And then the middle term would be composed of those two things. So the middle term has to have half of this guy's degree. Not just for me. I got to be careful how I say this. Because we have factored shit. I think this factors. And see, that's not following. But I can actually factor it using synthetic. So what I mean is, if I want to factor it directly, then the middle guy's got to be half the first guy. Is that all right? And now it's just the same old thing. What factors of 4 add to be -5? And I think you can take it from there. I like it. Maybe. Let me see. Oh, yeah, cool. All right. And again, just to remind you guys, if I answer your question, you don't have to just say it's good if it's not good. I always worried somebody's like, I have no idea what you're saying, but sure. You can ask a follow-up question. All right, anything else from homework or the quiz? If you had a chance to look at that, I finished grading most of them. Grade all of them. There's maybe a couple with some issues. Okay. All right, so I have several things. The very first thing I want to talk about is the fact that we're missing 14 people, but I'm going to try to get over that. Currently, there's a quiz scheduled for next Monday. That's even a little evil for me. So past Jeff apparently had something out for you guys. So I apologize on his behalf. Oh, I got another question, just a second. So let's do this next Wednesday. The quiz on 56576162. So I have adjusted the homework due dates, if you take a look at the due dates. And just a reminder, I try to tell each of my classes this. If you believe a due date is incorrect, like maybe I haven't updated it after some discussion, just shoot me an email. Just do that for me, all right? I'm trying to look out for you. You can look out for me. It's a little more to keep up with in this environment, so I'm not trying to be an asshole, not more than I am, right? So just keep I'll tell you, if it turns out that I like the homework due date, then I'll just say, I think it's fine, too damn bad. But you never know. Maybe I'll agree with you. So somebody's got a question from the quiz. Oh, yeah. Do you guys remember I was hoping you guys would have taken note of this. How do you factor this? I shouldn't have to do any, or I should be able to factor this right now. Before this class, you would say you can't factor it.
It would
But
be
now we're in this class. Say again, sorry.
x plus 7i times x minus 7i.
Kick ass. And I didn't take points off. Some of you guys were doing stuff like setting it equal to 0, which is actually fine, as long as you go back and you construct the factors from it, right? Don't just get the answer. So if you subtract 49, take a square root, you can see the I coming out. That sounds painful. And then you can throw those back in. But somebody did this and forgot to put this back together. That's what I needed to see. And of course, there was extra shit too. I think the problem basically looked like this. And then there was like an x squared or something. So this is a normal difference of squares. This is an abnormal difference of squares. And then this dude just comes from the right, right? So everybody had this problem, but nobody had this problem. I don't think I've said that yet this semester, but if you understand what I just said, you understand math a little better. Everybody had exactly this problem, but nobody had this problem. Okay. Jasmine, was that a, I'm sorry, I'm calling you out. I think you were trying to answer an earlier question. Yeah, I'm sorry, buddy. Okay. All right. Anything else? Homework, quiz. When are quiz corrections due?
Day of the final.
Yes. Let's see. Got a strange question here. Let me reply to it. I love you guys. By the way, I don't know if I kind of assume people know how Zoom works, but you know there's a participants at the bottom and a chat at the bottom. So if you click participants, you can see everybody else who's in here currently, right? Let me see. Yeah, dude, if you got a 99 on the quiz, you can still make corrections and try to get that point back, right? Why? Yeah, I mean, 1 point could be the difference between a B and a B plus or something. You never know, so why not? So yeah, if you got a 94, do the corrections. You'll get 5 points back if you do them all and get them right. Oh, okay. You're welcome. Certainly. All right. And the people that don't do corrections, I don't understand you. I really don't. I wish I had teachers that let me do corrections. Anyway. So no more questions, homework, quiz. If not, I've got a little outline of stuff I want to cover. Okay. So first thing I want to talk about is coming back to log and exponential form and just talk about how to convert between them. So let me see who was paying attention. So if I have an expression, logarithmic expression, log base b of m equals w. I know things get weird when we throw nothing but variables in there, but we definitely should be past that. How can I rewrite that in exponential form?
B to the W equals M.
Yeah, b to the w equals m. You can always do that because that's the base. What does a log always equal? What does that always represent? A log is a, who remembers? No?
It's the power.
Yeah, a log is a power. So we will eventually talk about properties of logarithms, and they will be the exact same as the properties of powers because logarithms are powers. So of course they have the same properties. Okay, I like it. So Let me see. What if I had this? Let me see who else was paying more attention even. Log t equals a. What seems to be missing, but it isn't really.
10 to the a equals t.
Yeah, because the base is known to be 10. The same way that if I write this, you know that's the square root. We just don't write a 2 there. That looks weird, doesn't it? It does. It does look weird a little bit, right? So the first time I wrote this, it looked weird to me. That's the same thing. Yeah, there, weird ass dude. So I know it's 10 to the a equals t. I like it. I like it. So that's pretty straightforward. Kick ass. We used that fact to help us solve a logarithm yesterday that we couldn't do. So let's just do a little review real quick. How do you spell review? There you go, buddy. If I have log base 9 of 81, what would that be? Can you guys see this all right? Let me see, yeah.
Would it be 2?
Yes, why?
Because 9 squared equals 81.
Yes, so it would be 2 because 9 squared equals 81. Kick ass. So, what if I had this? What if I turn this around? I want you guys to notice an interesting feature. What do you have to do to 81 to make it become 9? What power? And remember, what else are powers? Fractional powers are also roots.
So would it be 1/2?
Beautiful, right? You guys see that? The square root of 81. 81 to the 1/2 power is the square root of 81, and that's 9. Let me see if you notice that. Oh, sorry.
Sorry, could it also be -2?
No.
Okay.
What would 81 to the -2 be? It would be 1 over 81 squared. Holy shit. I like it. So I don't want you to feel like you have to memorize this, but yesterday I pointed out that when this inside, the only time it's going to be a negative is if it's less than 1, in between 0 and 1. All right, I like it because what's the log base 81 of 1? And again, real quick, before anybody says anything, if you're still having some trouble with logs, you have to force yourself to say what it means. When I write a square root symbol down, you don't even think about what it means because you've internalized it. So what is this asking? What's the power that 81 needs? 81 to the what is 1?
0.
Yeah, there you go. So you have to just internalize what this means, the same way you've internalized what the square root symbol means. Okay, I like it. So let me do another one real quick. I want to make a point here. Down. Oh man, I didn't want you to go that far. What do you want to do, John? Let's do log base 2 of 16.
Four.
Yes. Let me ask you a question out of nowhere real quick, everybody. Does my audio sound all right?
Yeah, it sounds fine to us.
I noticed when I uploaded last night's, I looked at it real quick on YouTube and it sounded muffled. So I just want to make sure. All right. So this would be 4 because 2 to the 4th power is 16. What's this?
1/4.
Yeah, so I mean, do you see the pattern here? It kind of makes sense. It takes 4 2s to make 16. So if I break 16 into fourths, I get a bunch of 2s. So that's why this is kind of nice. So if I get a problem like this, like what, Jeff? I don't know. Yeah, something like log base 81 of 3. You can think log base 3 of 81, right? How many 3's does it take to multiply to 81?
4.
4. So then what's the answer to this one?
1/4.
Yeah, cool. I like it. I like it. I like it. So don't look at this as a bunch of stuff to memorize. Just absorb the stuff that makes sense. Because there are other ways to get these answers too, but this is a nice little trick to realize.
So for
All right.
something like this, we wouldn't have to show work, right? Because there's not really any work to show.
Oh yeah, dude. Yeah, if I said what's the square root of 49, and you said and I said show your work, then screw that. So some of these are going to be, you know, if I'm teaching like if I'm teaching this in a 110 class, or something, I might tell them that the work to show, like the work to show for this, would be 3 to the 4th equals 81. But who cares? If you got it from the frickin' calculator, then you can just rewrite it like that anyway. So I'm gonna have to kind of trust you, right? But a problem like this, you're gonna want to, you have to show work for this problem. What are you gonna do, Jeff? Let's do, yeah, I like that. That is. Now, to be honest, you don't. So I'm going to show you the long way we did it yesterday. And then I want to try to sneak into your brain a quicker way to do it. All right, sorry. So did anybody remember what the first step was for a problem like this? I can't really do this directly too well. So what can I let it equal? Do I know what the answer is?
A variable.
Yeah. And then how do I rewrite this?
81x equals 27.
And of course now, the reason this is going to work is because they're both based on what number?
3.
3. Of course, we just saw that 3 to the 4th. I don't know why I'm putting these there. 3 to the 4th is 81, so that's 3 to the 4x. And 27 is 3 to the 3rd power. So then, hopefully, very obviously, what's got to be true about these two things?
They're equal.
They have to be equal to each other. So you get x is 3/4. Now, let me try to show you a way to eliminate all this shit. So if I get this problem, and I can right now tell they're both based on 3, right? What part of him is 3 is 1/4, because that's 4 3's, isn't it? And if you don't like what I'm doing right now, you can always just do that. 1/4 of this multiplicatively is 3, and then how many of those do I need to make 27? 3. So I got to do 1/4 of 81 to get 3, and then cubed is 27, which is the same damn answer we got over there. Yeah. So really what I'm doing is, if I break this up into 4 parts, I get 3, and if I take 3 of them, I get 27. So it is 3/4 of 81 multiplicatively. I really hope that makes sense to somebody, because that's a cool way to look at that.
I'm so tired.
I understand. I understand. If you don't quite get that, it's not the end of the world. It's not something you would hear a lot of people say.
Yeah, I've never
Right.
heard anyone show it that way. It's pretty cool though.
Can
I
you do
know,
another
man.
example like that?
Not that cool.
Yeah.
Stop making his head bigger. Oh my gosh.
What's the matter? Oh, I don't give a shit. What's happening? I don't care. I think it's cool. That's all that matters to me. If you think it's cool, that's bonus. Yeah. But let me show you. So let's see. Well, what do you got, Jeff? Yeah, sure. 32, 8, right? So they're obviously both based on what number?
2.
2. So this is going to have 5 2s. So I want to break that into 5 parts. And then how many of those make 8?
3.
3. Done. Because 32. So what is stay with me. I'm just going to go a little bit further just to really hammer home. It's a beautiful analogy. What is like, hang on to that. Hang on. What does this mean? Like, yeah, let's do 1/5 of 10. What does that really mean? This is 1/5 additively. So how many 5s does it take to add up to be 10? 2. So 1/5 of 10 is 2. Now that's freaky as shit. I'm sorry. It's just the way it is. But does that, anyway, that might not help. I don't know. Damn it. So what I'm doing here, what does 32 to the 3/5 mean? It means 1/5 of 32 multiplicatively and then 3 of those. And that's why breaking it up into 5 parts and taking 3 of those, that's what makes 8. All right. I might have pushed it too far.
If it was log 8 to the power 32, would it be 5 over 3?
Yeah, perfect.
Okay,
So now you combine this with that other observation from earlier. So what's log 832? That'd be 5/3. Now, why does that make sense? If I break 8 into 3 parts, what is that?
2.
2,
Well,
right?
3 2s.
Yeah, and if I take 5 of those, doesn't that make 32?
Yeah.
All right, cool.
That
I love
blew
how
my mind.
it comes back on itself. I mean, anyway, so these connections are what's sometimes left up to the student to create, but I don't think we get as much time to play with this shit as we used to be honest, with the amount of stuff we got to throw in your brain. But that's cool. I just want to show you that real quick. All right.
What if there's no common base number between the two?
We're coming up on that. We got to get some help. That's when we're going to need, it's sort of like, there's a lot of tricks with, like square root of 50, I can still do something with it, right? I can still do something with it, but if I ask you what this is, I can't do shit with that besides estimate, right? So then I'm going to have to get calculator help. So when we get in this situation where the bases don't match, I still have to rewrite it in a form that I can then throw into the calculator. So that's kind of like the next level of what we're going to learn. Okay. Put your little box. So what was the next thing? Oh yeah. Okay. So we already know what this means here. That's just what's called the common log, which is base 10. All right, so we know that. What's the freakiest base that we've seen so far? It's kind of like we had to create its own letter.
Natural logs?
Well, okay, we're headed that way, but the base, E. So if I have base E, I'm only going to write this ever once because this doesn't even look weird to me. It hurts me to write that. So instead of this weird shit, we call it the natural log. And then there's really dumb math jokes about natural log cabins and shit, but oh well. I'll let you look that up if you want to. Don't. That's it. That's the punchline. And one reason we call it natural log, who remembers what E kind of captures the best? I can't even remember if I really told you this. I think I did. I did mention radioactive decay, right? If it was reversed, if it was flipped, that would be radioactive decay. But did I tell you what this is? If it's a base E, it really captures the rate of growth. So this would be population growth, possibly. Or just any kind of thing that grows. So that's one reason we call this natural log, is because base E is used to represent natural growth mechanisms. Okay, which is kind of neat. By the way, did I tell you who came up with the letter E to represent E? You could guess this, and you would be wrong for the reason why, but it was Euler. He didn't call it E because his first letter was E. He called it E because that was the next letter that he was using to talk about weird numbers he was running across. And that was one of the few that stuck. Anyway, sorry, enough history. So that natural law is actually nothing really special about it necessarily, except that it works with E and E does some nifty stuff. But it turns out it's the one we're going to use the most. You want to know why? Because it has the least letters to write. Because math people are frugal with their time or lazy. Okay. So you got the common log where they don't show a base. And then another situation where they don't show a base is when I have natural log. So let me ask you this. Let's see if we can combine some things. I'm going to take all this away. Can you rewrite this in exponential form?
E squared equals T.
Yeah, E squared equals T. And then on your homework, if you want to draw an E in there so you can do this, all right, I understand. So E squared equals T, yes. How about this one? You ready? I like this coming up in my brain. What's the log of the natural log of E to the 100th power? I'm going to stand over you for a little bit. I want you to realize how silly this is. What is this asking you? What does a log always ask you? Like, why is log base 3 of 9 2? Because what's this asking you? Why is it 2? What's the
What
question?
power of 3 equals 9?
What power of 3 makes 9? Or even how many 3's multiply to be 9? Because that's what exponents mean, right? So either way you want to say it to yourself. So what's the base here?
E.
E. So this thing is asking, what do I raise E to get E to the 100th power?
It's just 100.
Yeah, and I want you to really realize this. These are inverses of each other. Do you remember how log base 2 is the inverse of 2 to the x? Log base 2 of x? They're inverses. What do inverse functions do to each other?
Cancel each other out.
Got it. And then what's log of 100?
Just 2.
Just 2. I like it. All right, let me stop for a minute.
Will there ever be natural logarithm problems that have E like that?
Yes.
Okay.
Will they happen like a lot? No. But enough? Yeah. All right. I'm gonna erase this.
I have a question.
Yes.
So, at the bottom where you said that log 100 equals 2, the like 10 is imaginary right there. So you just have to
Yeah.
assume that there's a 10.
You ready?
Yeah.
What's that mean?
Cube root,
What's that mean?
square root.
How do you know there should be a 2 there, but we just have decided not to write it because square roots are the most often used roots. Log base 10 is the most often used log, which is why it's called the common log.
Okay.
Right? It has no like Richter scale, obviously. Living in the state that we do, Richter scale. It's based on logarithms. Decibels, right? Decibels, they always compare a jackhammer and a rock concert. I always love that shit. That's based on logarithms. On common logs, log base 10. So it's the same idea, Understood 10. Just like that's an understood base E. Okay. What about this? I really want to make sure you guys get this idea. What's log base 2 of 2 to the B? You can look at this two different ways. Go ahead. One more time.
Is it B?
B, yeah. So the two ways you can look at it is, what power do I raise 2 to get to the B? Well, freaking B. Or log base 2 and 2 to the power are inverses, so of course the answer is B. They kill each other. The same way that cubing a cube root will just look at those things. All right, maybe. So let me ask you here even funkier question. What is 5 to the log base 5 of W squared? Let me tell you the most direct way to do this. Again, remind me. Sorry.
I was gonna say, would it just be W squared?
Yeah. So these two are opposite functions. 5 to a power and log base 5, they will kill each other. So of course you're left with W squared. But let me show you the freakier way to look at it. Let's see if anybody likes this way. I like this way better. Of course I would. So when I see, let me ask you this. Let me see. If I just write this piece of it by itself, just this piece, what does that mean? What does that represent? What does a logarithm represent always? You could do
It would be
a logarithm.
5 to the power of what equals W squared?
Beautiful. So it always represents a power. This represents the power that 5 needs on it to become W squared. And again, just to really make sure you guys are with me, why is log base 2 of 8 3? Because this is supposed to equal what 2 needs as a power to become 8. That's what a logarithm always represents. So this is the power that 5 needs to become W squared. So when I raise 5 to it, of course I get W squared. That's this thing's job. Now, with that said, you can always just do this shit because that's the same amount of math. They're inverses of each other. All right, okay. But just in case somebody else was weird like me and likes the other way to look at it, I wanted to show that to you.
I have a question. If we get another number that's not 5, like let's say they went the same number, like how would we do
Got it. So if I had 6 to the log base 5 of W squared, here's what I would do. Nothing. Not a damn thing, right? Can't do shit. We can maybe do some shit, but it depends on if there's anything else. Like, is it in an equation? Is there something else happening? If there were 2 sides, maybe I could do some shit to both sides. But if this is just sitting here like this, you circle it. You say, I was done before you gave it to me. It's exactly like this. What's x squared times x cubed?
X to the 5th?
X to the 5th. What's x squared times y cubed?
Just that.
Can't do shit. All right, there you go. So these didn't match. I mean, if these match, you can do something. If these don't, all right. If these match, you can do something. If these don't, all right. It's sort of the same idea.
Makes sense.
In fact, it's even more the same idea as I originally thought it would be. Same bases, different bases, different bases. So that was even more clever than I was trying to be. That's crazy. So it's not me. All right, just got lucky. I like it. So what would this be here? little tiny one.
2.
2. They kill each other. Kick ass. Okay. Let's see. Oh, okay. So we've done some basic computations with logarithms, and I really want you guys to get to a point. Let me give you some rapid fire stuff. I want you to be able to do these relatively quickly. So let me give you a nice one to start off. Well, maybe a little bit of a twist to it. There you go. Enjoy that one. Don't say anything out loud. Just take a minute and try to do these. What you got, Chad? Oh, yeah, let's do that. Sure. All right, so try to do those 3. Now, these are a little more to them. These are not basic ones, but you should be able to attack them. All right, let me see here. So anytime this is a pure reciprocal of a whole number, whatever that is, the answer is going to be so that's 2. So what must that be?
-2.
Yeah, that's what's going to make it flip. I love it. So that's another example of a number between 0 and 1 in here will give you a negative answer because it's a reciprocal of something. This one, it kind of makes sense that the only way this could work is if this was a certain number of these, right? So then you can always just start dividing this thing by this. You don't know what the hell. And if you do that once, you see this. And by now you should know how many 3s are in 81.
4.
How many total 3s are in 243?
5.
Wow, I love it. And then let's see. Who wants to tell me, did anyone do this one
2,
the other way without having to do X?
What do you mean?
So one way to do this is to put an X here, rewrite it, write them with the same base, right? Did everybody do it that way?
2 go into 64 6 times.
There's a slightly better number to that'll work. 2 will work, but won't 4 work also?
Yeah.
And anything that keeps my numbers down is better. So 2 would still work. So if I break this into how many parts, I'll get 1 4. Maybe you guys don't like this. Let's do it the other way. So if I put an X here, because I don't know what the shit the answer is, how can I rewrite this? How do I rewrite this?
64 to the x equals 16.
And by the way, it looks like you're right. So 64 to the X equals 16. And then if I rewrite this to be 4 to the what power? It's 64. Third power. And this will be 4 squared. So then I know that these two have to equal each other, and I get 2/3. So the other way to look at this was to say, if I break this into 3 parts, 4, 4, 4, I need 2 of those 3 parts to make 16 done. Okay, either way gets you the right answer, so either way, I like it. All right. So, enough of that. Moving on to the next little idea. So logarithms are basically a new function to us. Some of you guys might have seen it before, but they're basically a new function. And what I'm always curious about a function, I'm curious about its domain and range. So if you know the shape of something, so this is an exponential, so of course a logarithm is going to be like this, which means I automatically know what the domain is going to be. Let me take them out. What's the domain of log x? If I look at the picture.
0 to infinity.
Yes, and what's going to be on the 0?
A bracket.
No. What's here? That's an asymptote, right?
Mhm.
So it equals 0. And of course, you never put a bracket on infinity. If you do, I want you to go pick up infinity and bring it to me. Because that's what a bracket means. It means you can get there, right? Okay. Is that all right? So of course, you know what we're going to do. So what's the difference between this then and this? These get very confused. They are similar, but I want you to, let me see how much I want to talk about that. So if I said, what's the square root of 9? That asks me, what does it take 2 of to make 9 when I multiply? If I say, what's log base 3 of 9, that asks me how many 3's multiply to be 9. So they are very similar, but this one wants to know what the base is. And I'm over-analyzing this. Is my Wi-Fi doing okay? I'm kind of tripping out. All right. Stay with me. This is neat. This one wants to know what the base is because the power is 2. Right? Does that make sense? So if I have a 3 base and a second power, I get 9. This one knows what the base is and wants to know what the power must be. So that is the fundamental difference between logarithms and roots. They are like right next to each other, but they are definitely different. Is everybody okay with that? You guys, does that make sense? So be really careful to not think about one and the other the same way. What's this guy's domain though? What's the difference?
They can be negative too.
No.
Can include 0.
Yeah. So when I say domain, I mean real numbers. I have to say over the complex numbers if I want to include them. So that's the real number. I don't know what that infinity is doing. Yeah. So now watch this. What if I had this function here? How would you find that guy's domain? It should be very similar to how we would find something equally funky with that. What's got to be true about what's inside here? What's got to be true?
Goes to infinity.
Well, more fundamental about that. The inside has to be what? Say again, sorry?
Greater than 0.
Greater than 0. So the inside has to be greater than 0. Remember, if I had this, how did I find this guy's domain? I'd say this has to be at least 0 because that's what it's allowed to be 0. So the domain is very similar. It's just that this has to be a strict inequality because you can't have 0 inside of a logarithm. Why can't you have, not even just graphically, but why can't I do this? Because what does that want? It doesn't matter what the base is, just put a 7.
It wants the power that'll give you 0.
And there is no power that will give you 0. Right? That sounded deeper than it really is. There's no power that will give you 0. But 7 to the negative billion, 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 billion is still not 0. So there ain't no power that'll give you 0. And then this you just solve. So when you get x less than 5/4. I like it. All right. So let me ask you guys to do something for me. That's not a big deal. I'm not going to spend a lot of time on that because it's very similar to that. You just have to remember logarithms are a little more strict. They can't equal 0. Okay. So let's see. I want you guys to do this for me. Let's see if you guys can think about this. You make a table of values so we can graph that more detail. So when you do this, for example, and if you really hate when I do this, I'm sorry, I can't stop myself. But a little side note. Some of you guys drive me a little crazy. If I had to make a table of values for this, I'm not going to put 2 in there. I'm not going to put 5 in there. I'm going to put multiples of 3, right? So I'll get nice outputs. Does that make sense? Because I get to pick the freaking inputs. Why would I be mean to myself? Sort of on the same note, by the way, a major side note is when you guys make scales, everybody understands the scale doesn't have to be the same here as it does here, right? It seems like, so if you have an intercept there and an intercept there, why would you take this out to 10? I would actually blow this thing up. So a lot of you guys have this insane, like crazy ass, give yourself some more room. You're the one making the scale. Give yourself more room. Maybe make each step a half. Okay, sorry. That was very side note-ish. So coming back here, I am not going to put 2 in there. That is not smart. What can I put in there? Think about it. Actually, don't say anything. Try to get a few values, and then we'll compare. All right, so somebody give me one value that worked.
1.
1. So what's log base 3 of 1?
0.
0. I love it. Somebody else give me another value you found.
3.
3. Crazy. Log base 3 of 3 is
1.
All right, give me another one.
9.
There you go. I was waiting for that one. So log base 3 of 9 is 2. Now give me another one that's less than 9. Another one that works, that's less than 9.
1/3.
Kick ass. There we go. Now we're thinking ahead. These are powers. So if they're negative, it's going to make reciprocals. I like it. So if I go graph this business, we do know the shape of it, so I don't need like a ton of this. I know there's an asymptote here because it's not shifted. So like that. I'm not going to graph that one because I don't want to go that far. So too bad. Man. So at 1, 0. So that is going to be on every unshifted logarithm. It's going to be that point right there. That kind of makes sense. And I've got 3, 1. And I've got 1/3 -1. So there it is coming at it. Oh, let's see how you do here. All right, not too bad. Make that big. So it's going to be the inverse of the old exponential. I like it.
How would the equation look if it was shifted, like up or down?
You totally already know. I really want, and it's almost like I planted you because the next thing I want to talk about is shifting. So I'm going to erase this. Why isn't it working? Why? So what if I had a different function? Let's put it in blood red. So what if I had this? Well, actually, let me ask you the way that you just asked me. What would I do to this function to make it go back 1 to the left 1? What would I do to it?
Would you put +1 in the x by the x?
That's it, yeah. It does not matter what the function is. The function? It doesn't matter. As long as where the x is, if you put something like x + 1, x - 7, I know that's going to be a left and right shift. I don't care what this function is. So if I know the shape of the base function, I can then very quickly graph this. Where's the asymptote go?
Left 1 to -1.
Yeah, so it'll be x = -1. And then this goes back 1. And then this goes back 1. And this goes back 1. And then, oh shit, can we do it again? Sure. So if I wanted to make a function that, let's say, goes right 3 and down 4 from this guy, what would that look like?
X -3 parentheses +4.
Yeah, x - 3, so that goes right 3. And then, sorry, what'd you say in the end?
Oh, is it -4?
Yeah, there you go. Because when it's outside, it does exactly what it looks like it's supposed to. When it's inside, it doesn't. It does the opposite. Remember that? Because I could add that over so it's with the y, and then it would. Does that make sense? You guys remember that? So
Yeah.
if I bring y back and I add the 4 over, now since I put it with its variable, it's going to do the opposite of this, down, and the opposite of that, right. But it's just because it's not with this poor little variable. That's why it does what it looks like when it's outside.
You still have to put the 3 though, right?
So, yeah, I'm sorry. Yeah, thank you. I got a little excited about that. Yeah, I can't suddenly change the base. That would have a very different curve to it. It would have the same shape. Does that make sense? I didn't really analyze if you change the base here, the curve will obviously be different. Okay. I don't know if I have enough room to do this. Let's see. So this will go over 1, 2, 3. Not there yet. So, and then down 1, 2, 3, 4. I don't really care about that. So where would the asymptote go? Of course, would go 1, 2, 3. Did I go in the right place? Did I start at the right number? 1, 2, 3. I can do it. And then every point would just move over 3, down 4. So that, one thing the book does a really bad job of, but maybe you'll disagree with me. Let me show you. Something that always drives me crazy about books is sometimes they treat things like they're brand new, and they really are not. So we've talked about shifting functions before, but if you look at section 6.4, see if I can do this without making you guys sick here. Where are you, shifts? They have this huge section about, they just go crazy and all this detail. We don't need that shit. Part of me wishes they didn't do this. Some of you guys might like it because it's a nice review, but then it makes it feel as if the logarithm has its own shifts. No, there exist shifts, and they act the same for any function. So a bigger part of my brain doesn't like they do this. It's the same old shift, right? That was really bad. I don't care. I'm tired. Okay, maybe. So that is not new. That is not new. I don't care what the shape of the function is. If I know what the shape is and I know what the shifts are, I can move it. And now we know what the shape of a logarithm is. Kick-ass. Let's see. That might be, let me see. What was the last thing I wanted to do? Oh, yeah. I was thinking about getting into, I'm not going to do that till next time. That'll be enough for today. You guys all right with that? Anybody upset? You're not getting your money's worth? You can complain to my dean. All right. Go tell her, what the hell's going on with this guy? So I appreciate you're here. I was only missing 12 people. But remember, next Wednesday is the quiz. And have a good weekend. Double check the due dates on the homework. I pushed some of them out a little bit.
Are we doing the quiz in the same way on Wednesday?
Yeah, it's going to be the same way.
Okay.
Due Wednesday or?
No, just like always, they'll be due the next day.
Oh, okay.
You have at least 24 hours because normally everybody should be able to find time in a 24-hour spot.
Okay, got it.
Yeah. So does anyone have questions? Anyone need to hang out afterwards? Good.
Actually, I had a question about my quiz, like my
Okay.
test.
Who's-
Okay. My name is Anaji.
There you are. Okay. I couldn't tell which one was lighting up. So let me look you up here quick here. Let's see. Ruiz. There you are. Okay.
So I had a question about number 2. I kind of get why I got F like messed up because I didn't like put the y-intercept, and I was basically going. I basically thought that like we had to do it by hand, so I thought
Yes.
that like you couldn't use the calculator to find out what the deepest like bottom of like the graph was. So you know how you circled the bottom of the graph?
Because exactly what you just said. There's no way you would know that the bottom went that far down without having graphed it.
Yeah.
So the only thing you know in that region is that f of -2 is -16, right?
Yeah.
So just with that knowledge, it should have just went down to -16 and turned. Do you see what I'm saying? There's no way you would know that it should go deep.
Okay.
So if you just did that because it felt right or something, okay. But like I said, you got to be careful of anything that's something you wouldn't know just by what you've done by hand. Yeah.
Okay, that makes sense. And then I had a question about A.
Yeah, I just
don't get it.
Just a little more. What degree? I see 3 degrees. Do you see what I'm saying? So.
Oh, okay. So I have to like be
'cause I had somebody
specific.
say the first piece is even, and I'm like, no, you got to look at the complete degree. So you have to tell me what the degree. You could say the overall degree is this.
Okay.
Okay. I just need to know it's coming from the right place.
Okay, that makes sense. Thank you.
Great. No worries. Is everybody else all right? Are you guys?
Yeah, I have a question about my quiz as well.
Yes.
It was about 4B. it was the one where you have to identify how many real zeros there are, right?
All right. I just, for some reason, closed it. All right. Doug, let me see. Number 4.
Yeah, 4B.
Oh yeah, so you just showed me no work or explanation or anything. So
Okay,
especially
sorry.
with negative real zeros, you have to show me what Descartes needs you to do, right?
Okay, got it.
If you would have showed me that, I would have been fine because the positive real zeros come straight from the thing itself.
Yeah, so just, okay, sorry about that.
You show me, I knew you probably thought it in your head or something, but I need to know where it's really coming from.
Okay, got it. Okay, well, thank you.
No props. How's everybody else out there? Anybody else here?
I had a question.
Yes.
This is actually the homework. So 5.6, it's asking for the domain, and 9 and like 12 and everything like that. And I got
Uh-oh. You still there?
the
Hello?
domain and the denominator, trying to figure out what it's. Hello?
Oh, you cut
Hello?
out there for a minute. You cut out there for a minute.
Oh, sorry. It's
That's right.
my internet became unstable all of a sudden. So I'm trying to figure out the proper way to do the domain.
And which one
for
are we
number
doing again?
9.
Number 9, okay.
For 5.
Oh, did you miss that? We talked about that one at the beginning.
You did, but what I was getting, and I don't know if this is too much. So for number 9, I had it where the denominator cannot equal -2, -1, 1, and 2. So what I was doing for the domain was -infinity to -2 where it's not included, or -1 to 0 where it's included. And then so basically doing the intervals where it's included and it's not included.
Yeah, and I don't even really necessarily require that, to be honest. You could just say x not equal to -2, -1, 1, 2.
Oh. Yeah, because I didn't want to do all that if it wasn't required.
Yeah, no.
Also, one more question. So the homework where we were doing the graphs, I know I was one of those people that pretty much made the graph look like exactly how it would be in the calculator.
Oh.
For, I think it was 5.3. And I got a bunch of X's in those. Basically, should I just do it how I would think it would look like instead of me actually looking at the calculator and making it match?
So in 5.3, oh yeah, so this is where we're talking about multiplicity and does it turn or
Yeah. Yeah.
so forth. Yeah, to make corrections, what sucks is you've seen the graphs. So you almost don't even want to look at the graph on your paper. And you just want to look at the work. You graph it based on the work you did. And it could look a little funky. It could look, but you're just not supposed to know things that you didn't know.
Right. Yeah.
So like I said in class, I prefer an ugly graph.
Okay.
Right? Because that means that it what you did. Because we don't have all the answers when we do this by hand. So our graph shouldn't look nice. But I think students feel like, oh, it's got to look perfect. No, I want it to look ugly. Not like wrong,
That's
but
exactly. Yeah. That's exactly why it looks the way it is. Because I was like, I have to make it perfect.
No, I understand. I understand the reasoning behind that, but that's why I like to try to tell people, don't do that.
Okay. All right. Okay. Well, thank you very much.
Welcome.
Have a good night.
Let's see. You too. Dalton, are you out there? Going once. Uh-oh. Going twice. I am gone.